Okay, so what we're going to look at now is we are looking at part of the assignment on page 235, right here where we looked at grouping. So we're going to be factoring by grouping. So the first example I'm going to do for you is number 47. And factoring by grouping is something that we use when we have four terms and we can't combine any of those terms. We don't have a trinomial with three terms or a binomial with two terms. So we're actually going to create a factored term simply by using grouping. So we're going to actually put pairs into groups. So what I'm going to do is I'm going to draw a line down the center. Because the first thing I'm going to do is I'm going to try to group with the problems or with the terms in the order they're currently in. So when you group, you're going to look at two sets of terms. So let's look at my first group, 5x and 5y. By grouping those two together, I can see that there is a common factor between those two, which is 5. Now, the reason I'm grouping is because there is not a 5 present in all four terms. And when you factor, you have to have that value present in all of the terms from which you want to factor it. I don't have a 5 in every term. I don't have an x in every term. And I don't have a y in every term. So I've got to find some alternative way to try to factor this out. So between the 5x and the 5y, I can factor out a 5. And when I factor out this 5, that leaves me with x plus y. Now I'm going to look at the second group, and that is the bx plus by. If I look at this group, I notice that both terms have a common factor of b. So I'm going to factor out a positive b. That will leave me with x plus y as my factored term. So where does this get us from here? Once we've done this and we have these factored, we will be able to now look at this as a whole. There's a plus sign there. And now I do have a greatest common factor between the two factored expressions I've created. What do these two have in common? They both have x plus y. That means that I can factor out the greatest common factor, x plus y, from both of these terms. That being my GCF, that leaves me with 5 plus b. And now I've just completed factoring by using grouping. Again, you find groups of terms that have something in common, have a greatest common factor, and you use those groups. And this normally happens when you have four terms. That's the examples that we're going to be looking at here in Algebra 2. So let's move on and let's do another example. So we just did number 47. Let's move down to number 55. If you look on your assignment, number 55 is x squared minus 2x minus 8x plus 16. Now, one thing I do need to note about grouping is sometimes the terms are not necessarily in the format that they're supposed to be in. Sometimes when we look at your groups, the groups don't match necessarily, and you have to rearrange those terms to get the groups that you want. But for our purposes, we're just going to keep them the way we are right now for these examples. These are already set up to where you don't run into that. Okay, so I have four terms here. And I could combine the 2x and the 8x, and that would give me a trinomial. And that would give me x squared minus 10x plus 16, at which point I could factor that out using MF-DARM, or just using our factoring. But I'm going to go ahead and use grouping in this scenario because we need to practice grouping. So after I've divided these, the first thing I'm going to do is I'm going to look at my first two terms, and I'm going to decide, is there a greatest common factor between x squared and 2x? And in this case, yes, we do have a greatest common factor, and that is x. When I divide the x out, that leaves me with 1x here from the x squared minus 2. So I've factored what I needed from that group. So let's go to my other group. And again, just so that we keep the format the same, There's your first group, and the green is your second group. So looking between here, I have to be careful because now I have a negative. I have negative 8x and positive 16. If you look at the factor I'm shooting for over here, I'm hoping that we get is my x term is positive and my y term is negative. In this case, they are switched. I have a negative x term and a positive, and a positive constant. So I want to get a positive x and a negative constant. So what I'm going to do is I'm going to factor out a negative 8. Because when I factor out that negative 8, that leaves me with what I want, which is positive x. And then if I factor out a negative 8 from 16, I have 16 positive divided by negative 8. That gives me negative 2. Now I do have terms that match. So I'm going to look just like I did in the first example. What do I have in common? The greatest common factor here is x minus 2. So I am going to factor out an x minus 2 from both terms. And that's going to leave me with x minus 8. So this is your final factored term. What you could have done, like I said, is we could have used MF-DARM, which we really don't need because we don't have an a term greater than 1, but we could have factored. I could have combined these two if I wanted to and done x squared minus 10x plus 16. And then, following the rules, what I would have done is I would have factored the 16, which would be 16 and 1, 8 and 2, and 4 and 4. Coming back to look at my equation, I would see that my C term is positive. So I'm looking for the sum of any two factors of 16 that would give me a value of 10. And I have 17, and there's my 10 right there. That's 8. So 8 and 2 are my two terms. Once I've found those two factors, I'm going to come over here, and I'm going to separate. I know that my terms are going to be x and x because I just have x squared. My a value is just 1. My b value, the positive or negative sign, tells me what value the largest factor is going to get. So I have 8 and 2, so since it's minus 10, I have minus 8. Now, because the C term is positive, what we talked about, that means when the C term is positive, both of these symbols have to be the same. Because now, to get a positive, I either have to have a negative times a negative or a positive times a positive. So I have negative 8, negative 2, which adds to negative 10. And as you can see, that's the same thing we get as when we group. So that is actually factoring by grouping. We also sometimes will have examples like number 60. So I'm going to do one more example of grouping. I'm going to do number 60. Number 60 is 20n squared plus 8n minus 15n minus 6. And once again, we've got a situation with grouping. You could combine the 8n and the 15n if you wish and use our regular factoring format, but let's just solve by grouping here. Let's factor this by grouping. So for me, I always write the line down the center so I can identify my two groups. Well, my first group is going to be 20n squared plus 8n. And here's what's unique about this one. I look at my two constants, 20 and 8, and I have a greatest constant common factor between these two, and that is 4. 4 does go into both 20 and 8. However, I also have a variable that has that's common to both of them, and that is an n. I've got one n at least present in each term. So not only am I factoring out a constant, I'm factoring out a variable as well. That's what makes this one different than the other two we've done. So now 20 divided by 4 leaves me with 5. And n squared divided by n leaves me with n. Plus 8n, 8 divided by 4 is 2. And then I had 1n and 1n, it's divided out, so that's it. 4n times 5n plus 2. Now I'm going to look at my second group of terms. Between 15 and 6, I have a 3 that can be factored out. But just like we saw up here, I'm looking for positive, positive. Here I have negative, negative. In order to create positive, positive, I have to factor out the negative. So I'm going to factor out a negative 3. When I factor out negative 3, that leaves me with 5n plus 2. So now I'm ready to finish because the greatest common factor between these two terms is 5n plus 2. So my first factor is 5n plus 2, which is my GCF between these two terms. And when I factor that out, it leaves me with 4n minus 3. Therefore, I'm finished. I've completed it. And that, again, is factoring by grouping. You could have also had the option of combining, like I said before, these two terms here and use this process. But it depends on the person whether you think it's easier to group or if it's easier to actually go through the factoring.